Hi, I'm Carl Vincent A. Limbo.
And I am Raymond P. James, and we're here to talk about the different formulas for differentiation, D1 up to D9.
Before we go further, let's know what is derivative. Derivative gives the basic method for differentiating function of a single variable. They develop a set of standard of formula by means of which the derivative of most elementary function can be determined with less difficulty to save labor.
Note, the easiest way to get a derivative of a equation is through this. You will let the exponent of in the equation as n. Then to easily get the derivative, you multiply the exponent to the constant, which is 12. After doing that, you subtract n by 1. Then you'll get the derivative. So 4 minus 1 is 3. Then same thing here, multiply, which is 4, then minus 1, then x. That's it.
Now, we know what is derivative. Let's go to the formula of differentiation. In the following formulas, u and v will be used to denote any function of x that are differentiable. Now, let's go to the first formula, or d1. d1, the derivative of a constant is 0. Our formula is d1, dc all over dx is equals to 0.
Now I'm here to talk about the example for the first formula of differentiation. If we are asked to get the derivative of this equation, y is equals to 5. Since the first formula for differentiation, it states that the derivative of a constant is always 0, then we can say that the derivative of this equation is equals to 0. So the first example was very simple. But what if we're asked this to get the derivative of this equation? It's safe to say that the derivative of a constant is always equals to 0. So then the derivative of this equation is simply 2x. How it happened, we'll talk about it later.
Let's go to the second formula, or d2. d2, the derivative of the product of a constant and the function is equal to the product of the constant and the derivative of the function. The formula is d over dx times c times the quantity of c, cu is equals to c times the derivative of u. Now, let's go to the second formula, which is d2. The derivative of the product of a constant and a function is equal to the product of the constant and the derivative of the function. The formula is d over dx times cu is equals to formula is d over dx times the quantity of cu is equals to c times the derivative of u.
An example for the second formula for differentiation. If we're asked to get the derivative of this equation, since that the second formula for derivation states that a derivative of a product of a constant and a function is equal to the product of the constant and the derivative of the function. If we apply that concept to this equation, the derivative of x is always equals to 1. So we will take down 5, the constant, and multiply it to the derivative of x, which is 1. So we get the answer as 5. The derivative of this equation is u as 5. So another example is for us to get the derivative of this equation. First thing we do is we bring down 2, which is the constant. Then we find the derivative of this function, which is 2x. After getting the derivative of this function, we'll now multiply to the constant. So now, the derivative of this equation is now
The third formula for differentiation is D3. The derivative of an algebraic sum of two functions is equal to the sum of their derivatives. Our formula is d over dx times the quantity of u plus b is equals to the derivative of u plus the derivative of b.
an example for the third formula for differentiation. For us to get the derivative of this equation, we first get the derivative of both functions. So which the derivative of 2x squared is 4x, and then the derivative of 3x squared is plus 6x. Since we're dealing with algebraic sum, we can further simplify this equation into, and that's the derivative of the equation. And another example is if we're given this equation. So if we get the derivative of this equation, we get the derivative of both functions. So the derivative of 2x is 2 plus 6x. Then since we can no longer simplify this, that's the derivative of this equation.
The fourth formula for differentiation, or D4. The derivative of the product of two functions is equal to the sum of the product obtained in multiplying each function by derivative of the other. Our formula, d over dx d over dx times the quantity of u times b is equals to u times the derivative of b plus v times the derivative of u.
First example for D4 is this equation. First thing we can do is we let u and let v. Let this first function u and let this second function v. Then we need to get the du and the dv. Du is the derivative of this function, which is 2x, while dv is the derivative of this function, which is 4x. After getting this, we can now apply it to the formula of D4, which is this one. So first thing we do is first thing we write down is u, which is this equation, multiplied by dv, which is 4, plus v, which is this equation, multiplied by the derivative of the first equation. Now we simplify. So simplifying further, we get and then we have the derivative of this equation.
We go to the fifth derivative, or d5. d5. The derivative of the n power of a function is equal to the n times the product of the n minus 1 power of the function and the derivative of the function. The formula is d over dx times the quantity of u raised to n is equals to n times u raised to n minus 1 times the derivative of u.
So given this formula, then we're asked to get the derivative of this equation. We represent the exponent as n. So if we apply the formula for d5 to this equation to get the derivative, we'll get, since n will bring down the exponent, which is 4 times multiplied by the derivative of the equation, which is 3. Simplifying further, we get now we get the derivative of the equation.
the sixth formula for differentiation, or d6. The derivative of the quotient of two functions is equal to the denominator times the derivative of numerator minus the numerator times derivative of the denominator, all divided by the square of the denominator. Our formula is d over dx times the quantity of u over v is equals to v times the derivative of u minus u, the derivative times the derivative of v, all over v squared.
So I forgot to mention the d4 and d5. d4, we can also call this as product rule. And d5, we can also call this as now we move on to now let's have an example for the d6, which is the if we're asked to get the derivative of this equation, first thing we have to do is we again let u and let v. Then we have to get the du and the dv. So the du coming from this formula is 1. The derivative of this equation is 1. Same as true with the second equation, also 1. So now that we have the du and dv, we can now use this given to this formula, which to get the derivative, which is v du multiplied by du, which is 1, minus u x plus 1 times the derivative, which is 1, over v squared. Now simplifying further, cancel, then 2 minus 1. So it was 1 over. Now we get the derivative of this equation. But this formula can also be called as quotient rule.
Seventh formula for differentiation, or D7. The derivative of y with respect to x is equal to the product of the derivative of y with respect to u by the derivative of u with respect to x. The formula for dy over dx is equals to dy over du times du over dx, where
Often use the formula D7 if we're given with y and u. For example, we're given with so if we're given these equations, first thing we do is we substitute u. There's each of the u's in the first equation. So now we simplify. Simplifying further, we get then the last thing we do is we get the derivative of this equation, which is 2x plus. Now we get the derivative of this equation.
the second to the last formula for differentiation, or D8. The derivative of y respect to x is equal to the reciprocal of derivative of x with respect to y. The formula is dy all over dx is equals to 1 or reciprocal of dx over dy, where dx over dy is not equal to 0.
Since we're always doing derivative with respect to y, what if we're given a equation which is not equal to y? Example, first thing we do here is we get the derivative. In this case, we can do the quotient rule. Let cancel. From the quotient rule, if we simplify this equation, we'll arrive to this equation, square root of y minus y plus 1 over 2 square root of y. So if we simplify this further, we get the LCD, which is 2 square root of y. Then if we simplify it, we'll get 2y minus y plus 1, cancelling the square root in the denominator and then in y. So after getting that equation, since we all know that y is always like that, we can multiply to simplify it further, we will multiply to the reciprocal of the denominator, which is 1 over y. Then simplifying further, we arrive to this equation, 2y minus y plus 1 over 2y square root of y. Simplifying this, we get y plus 1. Then we get the reciprocal of it. Then we will get the derivative of the equation.
The last formula for differentiation in this tutorial is D9. D9. If y is equals to the f of u and x is equals to the g of u, the derivative of y with respect to x is equal to the ratio of the derivative of y with respect to u divided by the derivative of x with respect to u. Formula is dy over dx is equals to dy over du all over dx over du, or dy over dx is equals to f prime of u all over g prime of u, where g prime of u is not equal to 0.
For the last formula for the differentiation, which is the D9, we're given with x and y. First thing we do is we get the derivative of x and y. Then we will substitute it in this formula. Derivative of y over derivative of x. Since these are factorable, we factor it, then we simplify further. We cancel 3u minus 3. We get u plus 1 over 2u.
Thank you for watching, guys, and we hope that this tutorial will help you. That's all.
I knew my rent was gonna be late about a week ago. I worked my ass off, but I still can't pay it though. But I got just enough to get off in this club and have me a good time before my time is up. Hey, let's get it now.